Hello, everybody. My name is Aaron Lee. I am a developer advocate at Solace, and I'm happy to talk to you today about event API products and how to maximize the value of your event-driven architecture. So as we have seen, technology continues to increase at an expanding rate. The world, during COVID, so much kind of digital transformation was happening. A lot of our traditional kind of brick and mortar stores had to move online. The need for real-time communication is becoming essential for better business agility, for customer experience, and that is giving rise to the need for event-driven architectures. So that's what we're going to talk a little bit about today. So, are you seeing any of these trends? Talking about event streams, event processing, distributing your events across global hybrid cloud data, multi-cloud infrastructures, an event mesh. Obviously, this is API days, so we're talking about API management, API portals, but what exists for the event-driven side, asynchronous APIs and event-driven portals. And some of the patterns that you might see in terms of like asynchronous event-driven data exchanges, right? Publish, subscribe, at most once, at least once delivery, fire and forget, replay. These are all things that, coming from the traditional RESTful API world, you need to kind of learn about how these things can benefit your architectures as you move towards a more event-driven approach, or combining them. So, quick agenda for today. Let's talk a little bit about APIs and events as a kind of just a level set. We're going to talk about what event-driven APIs are. Whoa, did that flicker or was that me? I don't know. We'll talk a little bit about event API products and event management portal, how you can kind of use these to kind of document, discover, design your event-driven architectures. And I'll give you a live example at the end using the event portal that Solace has built. And we're going to talk a little bit about the AsyncAPI schema specification. This is an open source online spec group that are building a specification for how to design or define event-driven applications and architectures. Okay. Oh, and yeah, there'll be a little demo at the end. I have a demo in the middle as well, just to keep it interesting. This is the workshop track, but we're not actually going to be doing any hands-on just because we only have like 45 minutes, right? So happy for you to come over to our booth afterwards and talk about this more if anything interests you. Now, you might not have heard of Solace, but you've probably used Solace in some way. We come traditionally from banking, from investment banking. Most of the world's foreign exchange trades happen on Solace infrastructure. So if you've ever bought foreign currency, there's a good chance some of that pricing information or some of that order information went over Solace brokers. Here in Singapore, we've been working with the LTA. All the bus stop arrival information is sent over Solace infrastructure. All the bus telemetry data is actually sent into the LTA's data center for doing kind of pattern matching and routing. Nets is a big user of Solace. Every time you tap your nets or pay for something, that's going over Solace brokers as well. So we've been around for a long time in the event broker, the runtime space. But as this world has matured, we feel the need that there is need for how to kind of make it more accessible, talking about API products, event APIs, and the portal as well. So what are events? Well, they're all around us. They happen all the time. Anytime a user interacts with your application, anytime someone purchases something, anytime taps a credit card, a truck pulls into a depot, these are all events that are occurring in your architecture. And they can be emitted to other consumers that might want to be listening to these types of events, right? Pretty much anything can be thought of as an event, even like a purchase order, which you might think of like sending from your web app to your back end as a kind of a command, a service call. That could be actually an event that other applications might want to listen to. I got a few slides from Gartner here just because they're famous. The need for businesses to become more real time. The faster that things change, the faster that businesses have to think, and the faster they have to think, the more they need real-time awareness, real-time context. And the more you need that real-time context, the more you need to have kind of event-driven mindset. And, historically, maybe 15 years ago, the network was slow. Disks were fast. Databases resided at the center of your infrastructure. Everything went into a database. Applications would pull data out of a database. But now, the network is fast. The network is your nervous system. Databases still have an important part to play, but for real-time applications, you put the data on the network, and the network becomes the source of communication and truth for all these applications to listen to. So it's a real mindset from the IT, instead of the data custodian, is now more the nervous system, sending data, sending events, sending commands around your enterprise architecture. And there's a real need for speed, right? There's a real need for value. Again, this is the last Gartner slide I stole. So I think it kind of makes sense, right? There is real value to having real-time access to information. Your business wants it. Your customers want it. We're working with a very famous Swedish furniture manufacturer whose name I can't mention. And their primary use case was around inventory management. They had a big batch-oriented system that ran once a day. Then they tried to turn up the rate on that, once an hour. It wasn't scaling. They needed to rethink how their inventory system worked, not only from a business perspective, but as a customer, you're looking on their website and it says there are 2 things left in stock. And you get to the store and there's nothing left in stock. You know why? Because they haven't updated their database yet. So wouldn't it be nice if there was a real-time view as things are, purchased, stock goes down, as trucks come into the delivery, into the depot, stocks go up. Having that real-time view is beneficial from both the business and from consumers, right? Fraud detection, that's another great one, right? The faster you can detect these things, the more, the important it is. In retail, cross-sell, upsell, there's a real value to speed and being real-time. So let's compare, we're at API days, so let's compare APIs, traditionally RESTful APIs over HTTP with events. So APIs define how systems interact. They have defined semantics. They're defined usually using schema specifications such as Swagger or OpenAPI. And there's not a UI, right? It's a spec. Events are essentially state changes. Something has occurred. You can't rewind an event. It's like something has been clicked, something has occurred, something has been done in your infrastructure as a human, as a person interacting. And events specifically don't have a known destination, right? You don't say, I'm calling a specific service. Events are, this has occurred, and I'm putting it out there, kind of like a broadcast, right? Okay. And so they offer complementary patterns in terms of how these 2 types of things interact. RESTful APIs are traditionally request-reply. You do a get or a post into the back end, and you wait for that 200 OK to come back from the other side. You're requesting your data. Whereas event-driven architectures flip that around. It is a push-based model. So if you're waiting for an update, rather than continuously asking for whether something has occurred, you just tell me when something has occurred. So they both have their places. Obviously, request-reply is great for when a human says, I want to know something right now, click. But if you're just sitting there waiting for an update, constantly polling for updates is never a great solution, right? If you have a database at the center of your architecture and everybody's just constantly querying it to find out if something has happened, that's a lot of load on your database for like, nope, nothing's happened yet, nothing's happened yet. I'll just tell you when we get there, okay? So just, set up a subscription and I will push an event to you when something has happened. So they are quite complementary in terms of how they are defined, right? APIs, RESTful APIs are traditionally synchronous. It's a blocking protocol on the network. Event APIs, asynchronous. RESTful APIs, a pull or a poll mechanism. Publish subscribe. Who's heard of publish subscribe as a pattern? Out of curiosity, about half? Okay, so it's a one-to-many style of broadcasting, right? So where you'll have something in the middle, a brokered communication. You can see at the bottom here. With async, with RESTful APIs, typically you're talking directly to that endpoint, directly to the server, the web server that you want to talk to. With event-driven architectures, typically there's a system in the middle, a broker in the middle, that is doing that data kind of distribution. And the publish-subscribe pattern is a one-to-many style of distribution where the publisher will send one piece of data tagged with an appropriate topic, and the broker will manage which consumers are interested in what data, and will send that onward. So if you need to do 1-to-1, 1-to-2, 1-to-n, the broker manages that for you. The publisher does not need to worry about how many consumers of this data are out there, right? Think of a radio station. The person broadcasting the radio station has no idea whether there's 1, 10, or 100 people listening. They don't care. Everybody just tunes in to the station that they want to listen to. Protocols, standards. HTTP is a big one. GraphQL, gRPC, obviously, in a request-reply type events. Event-driven protocols have been later to the game. AMQP, MQTT are two big ones. AMQP stands for Advanced Messaging Queuing Protocol. MQTT, highly used in IoT applications. This is message queuing telemetry something. I forget, actually. Stomp is a kind of a text-based. But these protocols now exist that allow you to kind of, rather than using proprietary APIs like IBM MQ or TIBCO EMS, open standards on protocols to allow you to pick and choose, mix and match kind of best-of-breed applications for your use case. So when we think about events, one of the most important things is how do we label these events and how do we get them to our destination. So different brokers, Kafka, Rabbit, Solace, they look at topics in a slightly different way. I'm going to explain the Solace view of things, and you can come over to the booth and argue with me later about why it's better or worse than other broker implementations. But in our pub-sub model, we have a topic in the middle, consumers subscribe to this topic, and publishers publish to that topic. Now in Solace world, topics are hierarchical, so they can actually have multi-levels, where they can really define what's inside that event, that piece of data. So as a publisher, I'm publishing some data, and you can almost just know what is inside the payload of my message here by looking at this topic, right? I have an order created, and it's in Europe, for Unilever, and it's specifically ice cream, right? As a subscriber, I might want to subscribe to different pieces of this order flow. So for example, if I want to listen to all orders that have been created, regardless of what country they're coming from, I can use this fancy level, multi-level wildcard, right? So as long as it starts with order created, that's great. Or maybe I want to listen to only ice creams, orders that have been created or canceled or changed. Putting the different wildcards allows me to filter based on that topic. So this is very powerful kind of capability that publish, subscribe, or event brokers can give you. Similarly here, we have a payments topic, right? So this is a payments canceled for UK, blah, 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 blah. And you can see on my subscription, am I blocking this? Can you see behind me? Yeah? Okay. We have payments from the UK, or maybe all payments. So the consumer can choose what amount of the published data it wants to listen to. Last one, here is an airline example. We have Emirates, maybe it's a boarding pass app, what the status is, it's been scanned, and specifically for what flight and which location and where it's going. And as a consumer, you might want to listen to, all right, I want to listen to all Emirates boarding passes for a particular flight, or I might want to listen to all boarding passes for a particular carrier. So you can set up your subscriptions based on parts of your topic, which is metadata, essentially, for each of these events that you're publishing. The publisher defines the topic based on the contents, and the subscribers pick and choose, wildcards or not, what they want to be listening to. Just let me quickly flip over. I got this demo here. We are in Singapore, so I thought this was fairly appropriate here. Hopefully this works. Duplicate. Yeah, give it a, come on. My laptop is, there we go. Okay, so Singapore buses. This is not real data, this is simulated data. Those who know Singapore, you'll notice most of these are highways. Buses don't drive around on highways, right? But you can see here, this is just an example of kind of streaming real-time view of data. Every time one of these buses moves, it's generating a message, it's generating an event to say it has been updated. It's about every 5 seconds. We got about 500 buses here, so putting out about 100 events per second. And my map client here is subscribing to that feed of data. You can see at the very bottom, I have wildcards across the board. So I want the full feed of data. And you'll notice that the topic contains very specific kind of levels. So I want to listen to a particular route number, I can filter on that. I want to listen to a particular bus number, I can filter on that. Latitude and longitude, direction, these are all part of the topic string, which means my map client here, which is a JavaScript, Google Maps plus Solace API mashup, I can do some cool filtering. If I want to filter on, let's say, route number 7, I'll just add that as a subscription. You can see my subscription has been updated. Suddenly the message rate has dropped off because the broker is doing the filtering here. So the broker is filtering, not having the client receive everything and have to throw away stuff that it doesn't look for. And so there we go, route number 7, everything else kind of fades away. Great. What about, why is the location information in there? Well, that's kind of silly. Although, you could do something that looks like this. I've added a topic subscription. So, topics, we don't do arithmetic. We can't do greater than, less than. But it is just string matching. And so here, as long as your topic, which is the coordinates, matches this particular string comparison, think of it as a very cheap regex, right? A poor man's regex, I guess. You'll know that the bus is in this location. So just using topic strings, I can do some geospatial filtering of my event broker data. So if you're standing at a bus stop and there's 10,000 buses driving around Singapore and you want to see the real-time feed of just what's in maybe 100 meters of you, you don't have to subscribe to all 100,000 buses or 10,000 and filter out. You can basically ask the broker to do that for you. Okay, so there's my real-time demo. I think we're going to probably be playing this over at the booth as well. So let me just switch back here. Hopefully this doesn't cause any issues. There's my background. Switch to the slides. 1 second. All right, cool. Okay, so that's all about topics, right? So in terms of enterprise architectures, integration, we've come a long way. We had enterprise Java Beans back in the early 2000s, RPC, things like Corba, service-oriented architectures, moved into microservice architectures, APIs got really well defined, and then event streaming, and eventually event APIs. These are becoming much more commonplace as we move to support our real-time kind of requirements from our business side. Now, this is API Days. I'm not an RESTful API expert. That's not my domain. I am the asynchronous guy. So a lot of this, I think, should make sense. We have our API first kind of design orientation. We want to make sure that developers can find APIs that they want to use. Architects might create bundles of APIs, related APIs, put that on an API portal for people to find. Maybe data scientists are looking for things that they can query, and eventually make API products, related things that you might say, all right, hey, if you're building a web app for this front-end web store, here's a bunch of APIs that you might want to call to help make that work. There's been a lot of maturity in this space. We have portals, we have authentication, monitoring, all sorts of things around RESTful APIs. It's a very mature space, but event-driven space is still kind of up and coming. So there's not as much there, but it is being built right now. We're going to be talking a little bit about that. So yeah, wouldn't it be nice to be able to combine the power of APIs and all the technology and things that you can do there with events into one super awesome, high-powered. This is not my slide, by the way. I didn't know actually how to explain this one, but yeah, we're looking to supercharge our APIs and events by combining the best of both worlds. So let's take a look at kind of some API patterns. A typical traditional fully RESTful microservice architecture might chain their calls. Like if you have microservice A call microservice B, B calls C, C calls D. And these are all blocking calls, right? So you actually, when you look at latency or the overall kind of responsiveness of that first initial call, you're blocking, waiting for that guy at the back to kind of come back to you. Now, some things, in an order flow, should be synchronous to the customer, such as like your credit card authorization. That should be synchronous to the person saying buy. But there's a lot of stuff that doesn't necessarily need to be synchronous. So for example, the confirmation email or the rewards points, these could be dispatched off to those respective microservices in an asynchronous way. So I can kind of pick and choose, mix and match what needs to be synchronous and what needs to be asynchronous. I'm not saying that events need to replace all REST. That's not going to happen, and I don't think it should happen. It's just using each one where appropriate, depending on your architectures. And as we move to more event APIs, the generated responses or outputs of these event-driven microservices could be used for third parties, data as a service providers. Like the warehouse app could be emitting kind of some shipping notice updates, and there could be some analytics thing that is also like piggybacking and listening to that data for some new business case that maybe you didn't think of when you first started generating those events. Having those events available through a catalog, through some searchable mechanism, can allow a lot of kind of business ingenuity, I guess, to happen with that data. Okay, so all right, here's just an example of how we can kind of combine the two. At the DMZ, where the customer is interacting with your retail app, I'm going to place an order here. I'm going to get a confirm right away, but then that order management system might push data onto a broker that is going to send it onwards to other interested applications, right? And the order management might be, an API gateway. It might have some orchestration part of it, but orchestration versus choreography, the broker events are more about choreography, where you publish a piece of data and the downstream systems figure out what to do. There's no central governing orchestrator that's kind of managing everything, which could be a bit of a bottleneck. We used to see that in the SOA days. Yeah, so your apps could in the back these could be asynchronous. They might want to respond with a status update asynchronously when they're done. And yeah, talking about third parties, these events can also be subscribed to or sent to other third parties that might be interested in that data as well. So a real mix and match. Again, we're not replacing REST because that's why we're all here, but it's picking and choosing what to use when. Now, speaking of, kind of as a designer, as an architect, as a developer, when we're using APIs, there is the kind of the portal aspect, which is your design time, your kind of where you query things. There's a catalog usually, and there's your API gateway, which is your runtime, your management, the thing that actually accepts these calls, does some authentication, does authorization, and makes sure that everything is hunky-dory. On the event broker side, we've had, the runtime for a long time. Tibco, IBM, Kafka, these are event brokers that have existed for some time, some more than others, and that is your runtime. But what about the design time? What about the portal for asynchronous or eventing applications? Well, that is something that Solace has built, and I'm going to give you a quick demo later on. But it is required that not everybody is going and like using an Excel spreadsheet for all their topics and a Visio diagram to show who is talking to who. A Confluence page where all the schemas are defined. There's tooling available in the RESTful world, and this needs to happen in the asynchronous or event-driven world for businesses to really kind of move forward with these concepts. So for the runtime, obviously you need some way of moving data around. Solace makes event brokers. You can mesh them together in a hybrid cloud, multi-geo configuration, however you want, so that no matter where you are sending or receiving that data, the data will just get routed to where it needs to go. If you want to learn more about this, come over and talk to us in our booth. But we're about event API products, so that's all I'm going to say about that. So, as an architect, you're looking through the list of events that you have. You want to figure out, what are the important events in your system that you want to expose. You're going to have, obviously, your system events, how your applications are actually communicating with each other. Some of those are going to be important to across the enterprise. These events belong outside not just my app, but many other applications in different silos or in different parts of the business want to listen to that. So not just like your little inter-app communication. These are like the state changes that are important, like a shipping notification or something. And then these can be packaged up and bundled and presented as event API products, available so that a developer or somebody can come along, browse your catalog, and figure out what events can I subscribe to, what are the specs, what are the topics that they're associated with, and actually where can I connect to them to actually receive this data feed. So high value and exposure, right? System events, probably mostly the apps want to talk about that, but as we get higher up, they become more and more valuable, and how to integrate them into our developer portals. So 5 quick steps on how to create event API products. The very first thing you want to do is discover, I thought it was 1 click at a time, but I guess it's all at once. So we want to discover our system events, right? We've built maybe our application. We look at the data that's flowing around in them, or maybe through our specification, our design of the system, we pick and choose things that we want to look for. We assess the usability and value of these particular events. What do we want? This one's a good one. This one's a good one. Bundle and curate into the ones that we want to expose, provide some documentation around them, how to use them, how often are they updated, stuff about the schema, for example, release them, be able to monetize them, right? So again, exposing this data to third parties can sometimes have a lot of value. Just a quick example, we're working with this elevator company, and they have made all of their elevators smart. So basically, all the sensors that are on an elevator, how long it takes the door to open and close, vibration as it travels around, these are all generating events within the elevator, and they're actually using MQTT to have a real-time connection to their headquarters where they're streaming this data in real time. But they figured out, hey, you know what? We can actually sell some of this data to the casinos or the hotels or the businesses where these elevators are installed, such as arrival times, scheduling mechanisms, and the casinos can then make use of this and try to optimize kind of patterns in terms of where the elevator is going or where it's going to be. So I was like, that's a pretty interesting use case. Again, with publish subscribe, because it's one-to-many, all the publisher needs to be doing, the elevator, the order management system, whatever it is, publishes that piece of data once, and whoever wants to listen to it can kind of get a copy for free. So one-to-many makes it very, very easy to do. So we have our event portal. You can use it to document, to design. You can basically, rather than starting with code, you can actually build your application in a portal, graphical user interface. Say this is an app. The app has what events it wants to publish or subscribe on, define the schemas for those events. We've been building in runtime discovery capabilities. So a lot of our customers, because there hasn't been a portal up until recently, have already built their architectures. And so how do I find out what's already there? Now we're not building this just for our product. Like there's Kafka plugins, there's IBM MQ plugins, discovery agents that you can run in your runtime environment, and it'll listen to all the topics and all the consumers and the publishers and figure out who goes what where, and basically pull that data in to the portal to allow you to actually visualize what you have. We ran the Kafka discovery agent at a bank, a customer of ours, on a cluster that they thought they had a few hundred topics, and they ended up having 6,000 topics that they didn't even know about. The middleware, the infrastructure team had no idea. And it was because the developers had a very different mindset to how to use Kafka than maybe how it should be used. And so just giving that visibility into your existing architectures, what's out there, sometimes you don't know. I mean, unless you go looking for it, you don't actually know what's flying around. But because these are actually brokered communications, right? Publish subscribe goes through a broker for that distribution. There is somewhere you can actually look at it, measure it. We're building distributed trace as well into our open telemetry into our brokers to allow you to even more fine-grained access on what the data is that's flowing through your broker. So we have a catalog feature as well. This is something obviously you're going to need in a portal. What is where? I need some keyword searches. I want to know kind of what applications are available to me as an external user or as a developer within this particular app. You can even do things like analyzing dependencies. So in your runtime configuration, you can see which apps are talking to who, if somebody is publishing something that nobody is listening to, or if someone's subscribing to something that nobody is publishing to, and figure out if you change the schema on this particular event, who is it going to impact. After that, once you've defined all of your events, you can bundle them up as API products and provide them via a website with your credentials and kind of where to go. So we've actually made a headless version of our portal that some of our customers are kind of building into their own internal portals. So we can basically provide the kind of runtime event side information in whatever their particular things through APIs. We use REST APIs for all of our tooling to how to like build and access the event-driven portal. So that's all about the portal, and I'll give a quick demo in a bit, but I want to talk mostly about how the specifications for these event-driven systems has been coming about. Most people are familiar with Swagger, OpenAPI, I'm assuming? Yeah. Okay, so there is another specification called AsyncAPI. This was started about 6-7 years ago, I think, by some guys in Barcelona. It's an open source standard specification initiative. We are contributing to it, and there's a lot of other event broker, message broker companies contributing to it as well. And if you're familiar with OpenAPI, this spec will look very familiar to you. It's literally kind of channels, which are your topics, publish and subscribe, and schemas for the events. So an event is a topic and a payload. And that's pretty much what the specification says. Now you can use AsyncAPI for all sorts of things, not just documentation, but actually code generation as well. Let's looking at some kind of similarities here, right? So RESTful world, we have our API, hides all the messy details of how the application is actually using that, documented and described with OpenAPI Swagger originally, and provides ways of doing code generation. It's very similar for AsyncAPI as well. And of course, they can work together, right? One-to-one request-reply interactions, leave that as REST. That's great, that's perfect. But maybe one-to-many type of applications or asynchronous interactions, you might want to use an AsyncAPI specification or an asynchronous style of communication. But both of these can be used to generate events. Sorry, not both of these. The AsyncAPI can be used to generate events that then can be bundled up and provided to your third parties, to your developers, as event API products. Oh yeah, okay. Right, so REST, OpenAPI maybe specifies the interaction from that third party, and then your downstream systems can be specified using AsyncAPI. So they can really work together. Now, so really quickly, in an AsyncAPI specification, right, there are events, which is basically kind of like what is the payload of this thing. You can see I got a billing address, which is a string. I have a quantity, which is an integer, kind of very standard JSON schema. They are supporting other schemas as well, but everybody starts with JSON these days. You have events under processing, so like where is this data going? And also, it's a little bit hard to read. I guess we don't really need to read it, and where is this data going? What am I publishing on? What is the topic structure for this particular thing? Now, AsyncAPI is completely right. It's not for one particular broker. It is very generic. So there are code generation templates for Kafka, for Rabbit, for Solace, ActiveMQ, I believe, all sorts of ways that you can take your specification document and compile it into actually running code. Oh, and there's a slide here on the code generation too. Right? So take my spec, build some code, and that's what we're going to do right now. What time is it? How much time do I have? 5 minutes. All right, cool. Well, this is going to be quick. So let me just switch back to my screen here. Do you see buses? All right. Oh, thinking again. That's my colleague in Ottawa. He's building a cool plugin. All right, I'm going to turn this off for now. So this is our Solace Cloud. This is our kind of online application as a service. And this is the event portal. We have the designer, the catalog, and the runtime event manager. Very quickly, you can look at application domains. So each app team would probably have its own domain where you can specify what events and applications are defined within it. I made this little ecom demo here related to kind of like the examples we've been given before. I have some applications, my order service and a stock service, the events that are associated with them. You can see here I have order placed, stock updated, warehouse updated, the topic that's associated with each one. You notice some of them have squiggly brackets for variable substitution. Each event specifies a schema as well, so there's schema here. And what you can do then is go ahead and actually generate AsyncAPI specifications. Oh, I think I have to go into the right version. It's all versioned as well, so if I'm picking this particular version, version 1, I can go ahead and download AsyncAPI specification. Now, I could do that, or I could show you this plugin that we have for IntelliJ. As a developer, I am a developer advocate, so I always like to have a little bit of code here. I can go and query all of this exact same data. So using our RESTful APIs to access the portal, I can go and query that data, the exact same that we just saw, pull it up here. Can you see that? Is that big enough? And here is my ecom applications that I just had. So the app version. And if I wanted to write an app, I could actually do code generation right here in my plugin. So let us pick the stock service here. I'll just pull up the AsyncAPI for that. So here it is, just what we were kind of talking about before. It specifies kind of the name of the application, the payload, the schema there. And I'm going to go ahead and generate code. It's going to be a Spring Cloud Stream app. There's other binders and other configuration available. And I'm going to open it right here. So again, this is like my application I built inside the portal. I specified the JSON schema. I said which apps are subscribing and publishing on what. I've come here and I've browsed it. And as a developer, I can now have this little template framework with some basic, default connection values. I'm going to connect to my local broker here, but you can also connect to other brokers elsewhere and can actually run this thing. So I'm just going to go ahead, watch this, and run it straight away based on the topics, the events that I was, as my application was allowed to see. All right, it's booted up. Without any data, though, I'm not going to be able to do very much, right? As a subscriber, I need someone publishing data. Luckily, I have a little test app here configured with some topics and some payloads. I'm going to start publishing that, and right away you can start seeing that my application has started to receive some of that data. It doesn't do very much. It's just kind of echoing things to the console here, but as you can see, this is where you'd go and actually add some business logic. So basically, it's abstracting away all of the broker configuration, where you're actually connecting to, and you just, as a developer, have to do your business logic. All right, I've got an event saying the order has been created. I better go check the warehouse. I better go check my other applications, make sure the stock is enough. And maybe if the stock is getting low, I might then have to emit another event telling the stock or the warehouse to go order more products, for example. So yeah, anyway, really quick kind of walk through the portal. Again, come over and check out our booth. We're going to have a lot more kind of demos and things running there. But I guess in closing, let me just put that slide up one more time. Can I switch sides? Is that showing? Oh, good, it's showing. Okay, so key takeaways, right? Events APIs extend, they give this scalability. They allow your architectures to become more real time, to become more asynchronous. And again, think of like Twitter, right? You subscribe to a hashtag. Publish subscribe is kind of like that for your enterprise. I want to listen to all the shipping updates. I want to listen to all the order updates. I want to listen to all the whatever. You just subscribe to that data, and the event mesh will figure out where it can get to and how to get it to you. And AsyncAPI is the specification, well, the leading specification right now for asynchronous communication and building these apps. So yeah, that's it for me. I think that's my last slide. Yeah, there we go. Come visit our booth. As a developer advocate, I'm always encouraging people to sign up for Solace community. So if you really want to try Solace, you sign up for the community, you'll get some swag. And it's our question and answer forum, essentially, where Solace developers hang out, answer questions. Typically, people don't sign up until they actually start using us and have some problems. But I hope you do start using us. So what does this mean? What does that mean? I have this problem. So yeah, that's it. I'll take some questions if there's time, but again, come over to the booth if you want later, and I'll be there. So thank you. Oh, it's always running actually. So the bus demo, if you want to like check out the URL, it's running in the lab here in Singapore. So Solace office in Singapore is our second biggest office after Canada. And we have a little lab there. And so if you look at the URL there, sg.solace.com/bus. This is my little bus demo. It's a very visual way of explaining topics in PubSub and filtering that we tend to like. We often show it at events that we go to. I'm sure it's going to be in the booth later on. So yeah, and so the geo filtering part was kind of a little algorithm that I kind of came up with. Let me just, as an example. So when I move the shape, you'll notice like it's decomposing these. Each of these little orange squares is a topic subscription on Solace. So I've written a little app that basically takes the polygon as input shape and it decomposes it into smaller and smaller squares to approximate that shape. And each of these is a topic subscription. So essentially, using the broker's pattern matching on text, which is quite basic, to do something a little bit more fancy. So I have 193 subscriptions here, which approximates my shape to 90% accuracy. So again, as a subscriber, I'm UPS. I only want to know about trucks once they've entered the 100-kilometer radius of my depot. So I can do that with Solace, draw a circle, and it'll give me maybe 30, 40, 50 subscriptions. And again, subscriptions on Solace are quite cheap, right? You can have millions of subscriptions on one of our brokers. So having this kind of accuracy is quite nice. And again, the data just gets pushed to you when that pattern matches, which means that that GPS location is inside that topic or subscription or whatever. So it's real time, but it's simulated. So this is not real buses. These are not real buses driving around Singapore. I have a Java application in the back end publishing this data in real time. The coordinate data, I actually use Google Maps. So like when you do a directions API, you say, I want to go from here to here. Part of the resulting response, that JSON, is essentially a polyline that shows you that route. And you can take that polyline and ask for it in latitude, longitude coordinate pairs, and you get this big long string of coordinates. And then I just essentially every 5 seconds, I broadcast the next coordinate. So that's how my buses stay on the roads. People are always wondering about that. But yeah, they're driving on highways. All these buses are driving on highways. This is not real bus data, right? One day I will access the LTA's bus database, and because they provide for each route, there's an open API for buses, but it's all request reply, right? And so I actually wrote an app for my at our condo. We kept missing the bus, so I actually wrote a bus stop app that will tell you the location of. Do I still have it? Is it still running? And it's basically using Tanglin bus stop. Is that the right URL? No, I forget. Anyway, I'll show it later at the booth. But yeah, basically, I'll fix these buses one day to make sure that they're driving on their actual routes, not on the highways. So anyway, any other questions about buses or event-driven or anything? Again, come over to our booth. We're in the main room. And anything else, Joey? Okay. Thank you very much.